Okay, sorry about the terrible lighting, but I was just like on my way home from the gym and I was like, we are getting through this program together. And if it means me like just making videos to explain shit, I and you can watch it a million times, we're doing this. Like I'm like determined. I'm determined to graduate together. Okay, so I just want to talk about like maybe like one concept at a time. Um, so let's first talk about respiratory acidosis. I feel like it's probably less common than like metabolic acidosis, but metabolic acidosis to me feels more complex, and I feel like respiratory acidosis is pretty straightforward. So, when we are looking at a respiratory acidosis situation, respiratory refers to which body system? Lungs. I know I'm like pointing my chest. Lungs. Respiratory is lungs. So in respiratory acidosis, the lungs are not functioning properly. That can be due to a head trauma. So let's say like the chemoreceptors are not like your limbic system back here, I'm pretty sure, that's like controlling your breathing is not responding to chemoreceptors. So your chemoreceptors are the receptors that pick up changes like in chemicals. Let me just make sure I'm right about that. Who controls the lungs? Which part of the brain? Autonomic nervous system. Okay. So it's brainstem control, medulla oblongata. Okay. So chemoreceptors in the brain, aorta. So in your brain, in your aorta, which is the thing in your heart that brings oxygenated blood to everything else, and carotid arteries, which are in your neck, they detect levels of carbon dioxide and oxygen in the blood to adjust breathing frequency. So respiratory acidosis could literally be due to like your medulla oblongata is screwed up, so you had like a head trauma, right? It could also be due to conditions like chronic obstructive pulmonary disorder, like in patients who have been smoking for years, right? So let's talk about just like, let's do a quick refresh about like lungs. This is good for me too. So when you breathe in, you're breathing in fresh oxygen, right? And it's going down your trachea, so down your windpipe, and it's going into, you have your trachea connects to like your bronchial tree, right? So you have like the left and right bronchus, and then you've got like the sort of trees of the bronchi that go to the bronchioles, which are the smallest little tubes, and those connect to your alveoli, which are like the little sacs in your lungs, right? So like if you look at a cross section of a lung, it looks like a sponge, right? It's got like all those holes in it. Those are the alveoli. So that's where your carbon dioxide oxygen shift happens. So when you breathe in, the oxygen goes into your lungs, goes down your trachea through the bronchial tree into each left and right lung, and then into the alveoli. So when that shift happens, um, your the exchange is going from carbon dioxide to oxygen. And who carries that in the blood is the red blood cells. So when the red blood cells are coming back, so they're basically coming back for oxygen, they're going in the heart, they're going, they go into the lungs, they change out carbon dioxide for oxygen. When the red blood cells, the heme part, is carrying the carbon dioxide, that's when it's called carbaminoglobin. Let me double check on that. Carbaminohemoglobin. So that's the red blood cell, that little non-nucleated. Remember, because it shits out its like nucleus and stuff, and it only has like I think like the mitochondria left. So it's carbaminohemoglobin when it's carrying CO2, and it's oxyhemoglobin when it's carrying oxygen. So it literally, through a complex process, will shift carbon dioxide and oxygen, and then it goes back, back into the left ventricle, atrium, ventricle, aorta, to the body. So that's how we get the oxygen. So in certain conditions, like in a COPD, you also, one more little like anatomy thing about the lungs. In your bronchial tree, right? Those bronchi, they have smooth muscle in them. So those smooth muscle are connected to the autonomic nervous system. So they will contract based on like blood flow, or you don't have conscious control of them. So you do, like, they have smooth muscle in them. So when you have a condition like COPD, right, you've got a lot of mucus buildup. Part of the problem is like, let's say in a long-time smoker, they've basically destroyed those alveoli, those little pockets of oxygen and carbon dioxide exchange. And so what happens is you have the different enzymes coming in. They are literally sensing the inflammation, and they start basically breaking down the alveoli. Like, it literally becomes the body's like trying to get rid of the toxicity, but it can't. On top of COPD, you're not just dealing with alveolar breakdown in the lungs, you're also dealing with like you have bronchial constriction, because they're responding to like the pollution of the smoke. And you just have over time, so between like mucus secretion, alveolar breakdown, bronchial like reacting and constriction to the smoke, you are literally not getting as much oxygen in, and you have more carbon dioxide buildup in your body, which then like definitely like end stage like lung disease from like COPD, you are dealing with respiratory acidosis, because you're basically, your body is unable to get rid of the waste. You literally like can't breathe. You can't breathe. So basically, any time you can't breathe, you have a buildup of carbon dioxide. So now let's go back to our respiratory acidosis, right? Let's say we have a COPD patient, and they're having a crisis, like a respiratory acidosis crisis. So the lungs are the problem, as we've discussed. The lungs are the problem child. Normal pH levels. Let's talk about labs. I want to talk about labs for a minute, because it's the labs that like a lot of these nursing questions are going to be really like focused on and like worried about. They want to know that you can look at labs and interpret that. So pH is an algorithm of 10 to the negative 7.4, for instance, and that is a normal like pH range. So when we are above like 7.45, we're going to be alkalosis. But in the case of respiratory acidosis, we're looking for something that's going to be below like 7.35, below 7.4. So like you could have like 7.34, 7.32, and that's like you're getting like acidic, So your pH level corresponds directly to your acid-base levels. So acid in this case, especially in like acid-based stuff, we're really looking at, especially in respiratory, we're looking at the partial CO2. So the reason why we call them partial gases, like partial CO2, partial oxygen, is because, like, why is this? Oh my God, I'm forgetting. Hold on, let me look it up real quick. This is good for me too. Why do we call them partial gases? I don't want to be wrong, because I don't want to kill someone, you know what I mean? Partial gases are named as such because each gas in a mixture acts independently independently to contribute only a part of the total pressure exerted on container walls. Okay, so you have a partial CO2, you have a partial oxygen, you do have other gases in your system. They are called partial because they only make up a certain amount of like the total gas volume, like in your lungs, in your blood, in your, right? So your arterial blood gases, there's multiple gases. And right now we're only looking at the CO2, and that only makes up a partial amount of all the gases in your arterial blood. So when we're looking at partial CO2 on a lab reading, that PaCO2 is directly related to how well or not well, in this case, the lungs are functioning, because we're still looking at respiratory acidosis, right? So when we're looking at the partial carbon dioxide, we're assessing, are the lungs expelling the waste of carbon dioxide or are they retaining it? So in the case of respiratory acidosis, we're having a problem with holding on to carbon dioxide, right? Which is why we have a lower pH. So when we're retaining carbon dioxide, we're going to have more of it, which means that that number is going to rise. And our partial carbon dioxide should be between 35 and 45 millimeters of mercury. I'm just going to double check that. Lab values for PaCO2. 35 to 45. Yep. Okay. Okay. So your normal lab values for partial carbon dioxide are going to be between 35 and 45. If we have a respiratory acidosis situation with our COPD patient, the partial carbon dioxide is going to be higher because we have more of that carbon dioxide that is causing a change in your pH. So when you're looking at a question that's like, based on these lab values, what is your thing? And you see a high partial carbon dioxide, the body system we're associating with that lab value is lungs. And we're looking at between the range of 35 and 45. And if it's above 45, we have a problem with the lungs not working properly. They're not getting rid of the carbon dioxide. So it's just building up, right? It's causing an acidotic situation. So basically what's happening is the lungs are not working. So symptoms are going to look like shallow breaths, probably pretty depressed, especially like if they're in a coma or if they're like having to be attached to like an iron lung. I don't know what the proper term is, especially with like someone who's maybe got like a brain injury and their medulla oblongata is like screwed up and it's not responding to chemoreceptors. You're going to see basically like the lungs are not working. So you're going to probably have to put them on like a ventilator. Ventilator. Jesus, that's the word. You're going to have to put them on a ventilator, right? So that's your basic respiratory acidosis. The most important thing we're considering is that it's a lung problem. We are going to be looking at partial CO2s as lab values to determine that the lungs are having problems working. We're going to want to also take a look at like what is the underlying condition. Like, is this a secondary respiratory acidosis to a head trauma, or is this to COPD? Like what is going on where we can maybe treat that underlying problem and it's going to fix itself, right? I want to get into compensation, but I also just kind of want to let this sit and just sort of like get comfortable. So I think in the next video, we'll talk about different types of compensations, but like very briefly, compensations are basically what happens in the body when one system goes wrong and another system that regulates that same sort of patterns of labs like CO2, oxygen, all that stuff. We're looking at how is the body making up for that lack of supply in order to get back to homeostasis. So that's kind of like what compensation is. It's when two systems kind of are working together to maintain homeostatic levels, and when they're working like partners, like you and me, we're working to maintain homeostasis in this fucking program. And if I all of a sudden had like a fucking brain injury that caused me to be unconscious for like 2 days, what would be the things that you would do? Like, not that, it's just an example. Like, I, like, what would be the things that you would do to like kind of compensate? And that's what we're looking at is like, if your lungs are screwed up and they like help with acid base balance, and kidneys also help with acid base balance, how are they working together? And then when one system's screwed up, how is that other system making up for the lack of like function, you know? So when we're considering like different compensations like in different body systems, we're not just thinking about like how does this system function? Like how do the lungs work? How do the kidneys work? We're thinking about like the umbrella state of what the homeostatic goal is. Like in this case, our body wants to maintain acid base. That's the umbrella. What are the systems that work under that umbrella? So we want to start to just like build our knowledge in layers, so that when we get to questions that like honestly like we don't know the answers to, we have all these patterns and we can just be like, okay, like I don't know this, but I know enough about this in order to be able to answer the question. Okay, that is like a almost 17-minute video, so I'm going to stop it there. I hope this is helpful.